Hello, welcome to my channel. We will be doing question number 3, chapter 16. It's a pretty straightforward question. Okay, we are given that the velocity of an object as a function of time is given as e to the power 2t minus 6 e to the power minus 2t minus 1. Okay, so the first part is that find an expression for the displacement. Okay, remember derivative that we call s as the displacement. So derivative of the displacement is speed. So the integral of speed will give you the displacement. Okay, so the displacement as a function of time is going to be the integral of the speed. Okay, so if I try to integrate this expression, it's going to be e to the power 2t divided by 2 minus 6 into e to the power minus 2t divided by minus 2, and minus integral of 1 is t, and then we have a constant of integration. So it will become 1 by 2 e to the power 2t, and this will become plus 3 e to the power minus 2t minus t plus c. Okay, now, 1 second, I need to, okay. Um, Now we know that, 1 second, I had to see a particle moving in a straight line. Okay. Uh, yes. And we know that it was passing through the origin at 0, right? Because yeah, it said that t second after passing the fixed point O. Yes, so that if I call this point O, then at t equal to 0, the distance was 0, right? So the distance s is 0 if t is 0. When t is 0, something equal to 0 is 1. So it is going to be 1 by 2 plus 3, because e to the power 0 is 1 again, minus 0 plus c. So this gives me the value of c as minus 3.5, right? So 3.5 is 3.5, and c is equal to, it will go on the other side, is minus 3.5. Okay, so my expression for the displacement as a function of time is going to be half e to the power 2t, and then plus 3 e to the power minus 2t minus t, right? Minus t and minus 3.5. So this is my answer for part 1. Okay. Now, the second part of this question is using the substitution this or otherwise find the time when the particle is at rest. Okay, particle is at rest mean the speed is 0. So I will substitute v0 in this expression. So it will become 0 equals e to the power minus 2, so 2t plus, minus 6 e to the minus 2t and minus 1. So I need to solve this equation, find the value of t. Okay, so we will do this substitution, that e to the 2t is equal to u. So using this substitution, I will have 0 equals u minus 6. Okay, this can be written as 1 over e to the 2t. So it is going to be 1 over u. Make sense? Minus 1. Okay, so if I, if I multiply everything by u, it is going to be u square minus 6 minus u equal to 0, or u square minus u. mm, Uh, I made a mistake, I believe. Hold on a second. No, this is correct. Yes, sorry. Minus 6 equals 0. So this can be factorized as u minus 3 and u plus 2. So minus 3 plus 2 will give you minus 6. And yes, it will give you minus 1. Okay, good. So from here, u has two values, either 3 or minus 2. Okay. Now, if u is equal to 3, it means e to the power 2t, this is equal to 3. Okay. And if this is equal to 3, let me erase this part. Okay. Yes. So if I take log on both sides, then 2t is equal to log of 3, natural log of 3. And from here, t is equal to 1 by 2 log of 3. And 1 by 2 will become power, so it will give you log of under root 3. Okay, so this is the value of t. Now, if u is equal to minus 2, so e to the power 2t is equal to minus 2. This have no solution. There is no value of t that if I raise e with that power, it will give you negative number. So it does not give you any solution. Okay, so the only solution we have is t equals log of under root 3. Okay, this is my second solution. And the units of this time is going to be second now, of course. Okay, now the third part, find the acceleration uh, at this time. Okay, remember acceleration is the derivative of the speed. Okay, so in order to find the acceleration, I need to differentiate the given expression for the speed. So acceleration as a function of time, it is going to be, if I differentiate this speed, it is going to be e to the power 2t into derivative of 2t is here. Similarly, minus 6 e to the minus 2t, and the derivative of minus 2t is minus 2. Okay, and 0, the derivative of 1 is 0, so it will become 2 e to the 2t, and minus minus plus 6 times 2 is 12 e to the minus 2t. So this is the acceleration in terms of meters per second squared. Okay, find the acceleration at this time. So we need to find the acceleration at this particular time. Okay, so acceleration when t is log square root 3, right? This is equal to, now remember when t is log square root 3, uh, e to the power 2t was 3. Okay, e to the power 2t was 3. So I can substitute this value directly. So it will give you 2, and e to the power 2 is 3 plus 12, and this is 1 over e to the 2t, so it is 1 over 3. Okay, I hope this is clear. This is the theta to 6 and plus 4, that is going to be 10 meters per second squared. Okay, I hope everything is clear. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.